Yes, so guys, now you are getting my voice. So let me start the session from the beginning. So guys, okay, so Jayapriya, now you are getting the voice right. So guys, this is the EMT Abhyas series, and we are bringing this series for the question practice. And in the today's session, we are going to solve the questions of the transmission line. Okay, and before starting this session, if you are not aware about me, so this is Saket Verma, and I have done MTech from IIT Guwahati and created different PSU exam as well. So these are the subjects which I teach, and this is the Telegram group. If you want to join me in the Telegram group for the more updated session, that upcoming session, and also for the PDF, then you can join this Telegram group. And we are bringing one monsoon series. This is the summer series which we are going to finish within this week of month, first week of this month, July, and then we are having the monsoon series, and where we are going to discuss the again some questions, some concepts in this free series. And this is the 7 month workshop because the gate is left about 7 months. So this is the workshop where you will get an idea that in the 7 month how can you get the top 100 rank, and that is going to be held on 2nd of July at 12 p.m. by Dheeraj sir and by Abhinav Negi sir. Okay, so now you can start this solving the problem. I have to put that stopwatch again. Yes, so Jaipriya, now you can solve, है ना? चलो तो अभी सॉल्व करो इस क्वेश्चन को. So now 37 seconds left. Quickly solve this problem. Okay, so let's start discussing the problem. So as you can see that the load's resistance or the load is given as 80 ohms. So this is the pure resistive element, and the characteristic impedance is 50 ohms. So both are purely resistive, and if the load is pure resistive and if the load is greater than Z0, then we can directly calculate the standing wave ratio by ZL upon Z0. So this will be 80 upon 50. Okay, that is your 8 by 5. That is your standing wave ratio. Now, because you want to calculate the minimum input impedance, so in minimum input impedance will be, what is the formula for minimum input impedance? If you want to calculate the minimum input impedance, then how can you derive? Suppose you want to derive, then standing wave ratio is given as Vmax divided by Vmin, right? And we also know that the impedance is given by V upon I. So the I should be minimum and V should be maximum. Correct? Isn't it? Now, sorry, because we want to minimize this, so it is maximum. because we want minimum input impedance, so minimum input impedance will be when this will be minimum and the current will be maximum. Okay, so now if I substitute the value of V minimum, or because we want to, yes, so if I suppose substitute the value of V minimum, then it is S upon so we want to calculate the value of V minimum from the first equation, which is V maximum divided by S. So if you substitute this in this equation, so this is V max divided by I max into 1 upon X. V max and Is is Z0, so this is Z0 upon S. So this is the minimum input impedance. Okay, so the minimum input impedance is Z0 upon S. So you will use the formula Z0 upon S. Z0 is the characteristic impedance, which is already given 50, and S is also 8 upon 5. So now you can calculate it. This is 250 divided by 8. So 250 divided by 8 will be the answer. So this is 31.25. So answer will be option C. So let's see who has given the answer. Yes. Now coming to the next question. This is the consider the transmission line shown in figure. Here the two identical antenna, each of input impedance 100, are fed with the 50 ohm lossless transmission line. So characteristic impedance is 50 ohm. The input impedance at the source end. So we want to calculate the input impedance at this side, and all the transmission line are having the length lambda by 4. So you can write the Z in dash. This is the Z in dash for the input impedance for this particular line. So this is Z0 square upon ZL. So what is the Z0? The characteristic impedance is 50. So this is 50 into 50 divided by load impedance, which is 100. So you are getting 25. So this Z input is giving 25. And what about Z in 2? So Z in 2 will also be the same because the impedance is same. Characteristic impedance is also same. So this is 25. And both are in parallel. So the load impedance for this two transmission line will become, the load impedance will become 25 in parallel with 25, which is 12.5. Now for the overall input impedance, so for overall input impedance, Zin is equal to Z0 square upon the load impedance, new load impedance, which is the combination of the two parallel transmission line, and this is your 50 into 50, and ZL dash is 12.5. So if you solve this, you will get 25 into 5. This is 20. This is 4. So you will get 200. So Zin will be 200. So answer is 200. Correct? Yes. Now coming to the next one. An RF signal is applied to a 50 ohm lossless transmission line, which is terminated in a load with the impedance of ZL is equal to J50. The wavelength is lambda, which is the 8 centimeter. Find the position of voltage maxima and the current maxima respectively nearest to the load from the load end. So you know that the location of maxima is calculated by the formula phi upon 2 beta. Okay, maxima is obtained at the length of phi upon 2 beta from the load. Okay, phi upon 2 beta from the load, and phi is nothing but the angle of reflection coefficient or the phase of reflection coefficient. So what is the value of reflection coefficient here? The reflection coefficient gamma is ZL minus Z0 divided by ZL plus Z0. What is ZL? ZL is J50, Z0 is 50. So this is J50 plus 50. So the 50 will get cancelled. So we will get J minus 1. And let's rationalize it, J minus 1. And we will get J plus 1 and J minus 1. So this is J minus 1 whole square. So this is J square plus 1 minus 2J divided by J square minus 1 square. So we will get J. Okay, this will be minus 1, this will be 1, this will cancel, and in the denominator also we will get minus 2. So minus 2 and minus 2 will get cancelled, so we will get j. So we can write it as the 1 at an angle of pi by 2. So the magnitude of the reflection coefficient will be 1 and the phase is pi by 2. So now you want to calculate the maxima. So voltage maxima will be calculated as pi by 2 into 2 into beta. Beta is 2 pi by lambda. So when you solve this, this will be lambda upon 8. What is the value of lambda? The value of lambda is given as 8. So 8 upon 8 we are getting 1 centimeter. So 1 centimeter is the length of maxima where the voltage maxima occurs. And voltage minima or current maxima occurs in the distance of lambda by 4. Because the distance between the voltage maxima and voltage minima is lambda by 4. So this is lambda by 4 plus the maxima length. So lambda by 4, lambda is 8. So this is 8 upon 4 plus maxima length is 1. So we are getting the 3 centimeter. So the voltage minima will occur at 3 centimeter, or you can say the current maxima will occur at the 3 centimeter. So answer is option number A. Option A would be the right answer. Okay, so I think this is not properly visible. Okay, this is the length of the transmission line is lambda by 4 and the characteristic impedance is 50 ohm for all the transmission line. And there are N number of transmission line present. Okay, ZL1, ZL2, ZLN. So there are N number of transmission lines, they are connected in the shunt. Now you have to calculate, it is given that the overall equivalent admittance, okay, the overall equivalent admittance is 1.25. So the overall is 1.25. Now they are connected in parallel. So you have to tell them how many number of transmission lines should be connected. So we know that if I want to calculate the overall impedance, then the overall impedance is nothing but the 1 upon Z equivalent is 1 upon what? 1 upon the input impedance of the first, the input impedance of the second, and so on up to input impedance of the n. So nth input impedance. Okay. Now, because we know that 1 upon admittance is impedance is admittance, so this is Y equivalent, and 1 upon ZL1. What is the characteristic load impedance or input impedance for the lambda by 4 transmission line? So for the lambda by 4 transmission line, this is Z0 square upon ZL. So now we will substitute it here. The characteristic impedance for all the line is same. So this is ZL1 divided by Z0 square plus ZL2 upon Z0 square, because this is 1 upon Zin. So it will get invert. So it will get invert. So the ZL will be in the numerator and so on up to ZLN divided by Z0 square. So 1 upon Z0 square, which is 50 whole square, this will be common, and there are n load impedance are connected in all are same. So this is the n into ZL, and Y equivalent is also given. So Y equivalent is 1.25. It is multiplied with 50 whole square, that is 2500, divided by the load impedance. The load impedance is 25. So from here you will get the number of transmission line connected, which is 125. Got it? Now answer this one. Come on, answer this question. Okay, so let's start this. This is given as a 2.4 gigahertz signal is launched on a transmission line of length 1.5 meter terminated in a match load. So this is the match load and it takes 6.25 nanosecond to reach the load and suffers 1.2 dB of loss, the propagation constant. So the formula for the propagation constant gamma is nothing but a alpha plus j beta. So that means we want to write alpha and beta. So how do you calculate the alpha? It is as given that when it is traveling, it is suffering a loss of 1.2 dB. So but whenever we put in this equation of gamma, we get the answer in the meter inverse, where alpha is attenuation constant and put in the Napier. So we know that 8.686 dB is given as 1 Napier. So this is 1.2 dB. So how much Napier it will be? 8.686 multiplied with 1.2. So calculate this value and whatever it will be, this will be the value of alpha because the attenuation is the loss and it is directly given to us. Now coming to the beta. Beta is nothing but a omega by Vp. Vp means velocity. Velocity is nothing but the distance upon time. So how much distance it is traveling? The length of the transmission line is 1.5 meter distance traveling with the time of 6.25 nanosecond. So it is taking the time 6.25 nanosecond. So this is 2 into pi into 2.4 into 10 raised to power 9 into 10 raised to power minus 9 multiplied with 6.25 and whole divided by 1.5. Okay, so when you will solve this, this is 10 raised to power 9, 10 raised to power minus 9 will get cancelled and this point and this point will get cancelled and this is 5 into 3, this is 5, 105. Okay, so this is 3, 8, so 16 pi into 1.05 actually 1.05. Okay, this is 1.05. So 16 pi into 1.05, calculate this value and calculate the value of alpha. So 1.05 into 16 pi. So there it is, 16 pi into, I think we are missing something. Let's calculate it again. Okay, I think we are missing some data. Let's calculate it by the calculator directly. So this is 2 into 2 pi into 2.4 into 10 to the power 9 into 6.25 into 10 raised to power minus 9 divided by 1.5. Okay, so calculate it. This 10 raised to power 9 and minus 9 will get cancelled. So this is 2 pi into 2.4 into 6.25 divided by 1.5. Yeah, so I think there was some calculation mistake. So 62.83 we are getting as the radian per meter, and when you calculate this one you are getting 0.092 Napier. No, not actually 0.092, not, we will not get here. See, this is how much Napier? Let's calculate it also. 1.2 divided by 8.686. So we are getting 0.138 Napier. This is 0.138 Napier, but there is alpha is in the Napier per meter. So to calculate the alpha, we have to divide this divided by the length. Length also you have to divide. Then when you will divide, this will be 0.092 Napier per meter. So from this way you will get the value of alpha. So the answer is A, where the beta is 62.8 and alpha is 0.092. So thank you for watching this session, guys, and we will meet again tomorrow with the questions of antenna. Don't forget to subscribe the channel, and tomorrow at 8:15, in fact, again tomorrow at 8:15 p.m. to 8:45, we will be solving the questions of antenna. So if you will join the live sessions, definitely I will take more session of question practice. Okay, so come live, then only I will come to know that how many of you are actually need or look for this particular question, this type of question. If you are not looking for this type of questions, then there is no meaning of taking the session. So that is why I am waiting for you to answer and also to join the session live, because whenever you come live, we will interact, and when you interact with me, then only I will come to know about your requirement. Otherwise the random session we will take, but there will be no use of it, because maybe you are not looking for that type of session. So if you are looking for the question practice session, do comment in the comment section, and also come live and tell what you are looking for in the YouTube. So if you are looking something special for in the YouTube, then let us know. We will bring the series according to your demand. So for that, you have to subscribe the channel, and don't forget to download our BYJU'S exam prep app, because when you download the app from the Google Store, you will come to know that how many free lectures we are providing in the app. That is more than the YouTube. Okay, so to solve such type of problems, yes, so to solve such type of problems, guys, you can also join our vision batch, because there we do the lot of problems. So this is all about the session, and do subscribe the channel, and stay tuned with us, and join the Telegram group as well, for my channel also, and for the our main channel of the Telegram. You can join this particular group. Thank you. Good night and take care. Tomorrow at 8:15 for the questions of antenna.